So today we're going to talk about arc length some more. And today we're going to talk about all the problems that can happen when you're trying to find the length of a curve, right? So earlier, what we talked about is a smooth curve. Well, what does that mean to be a smooth curve? Okay. So in order to find the length, and I boldface this because it's really important. In order to find the length of a curve, it must be a smooth curve. And what that means is the function must be differentiable. So we're going to come across problems where there's a point where the function is not differentiable. And then how do we handle that? All right. So if you look at this, all right, this function right here, y equals x to the 1/3, recall, so this one is y. This is the cube root of x, because that's the same as x to the 1/3 power. And you look at this, and right here at x equals 0, we should realize, oh, there's a vertical tangent there, which means it's not differentiable there. Okay. So one way to handle this, okay, and I should write this. Okay, so we have a vertical tangent at x equals 0. Okay, so that's looking at this as y in terms of x. What if we rewrite this? Because for this one, our inputs are x and our outputs are y. If we rewrite it with y as our inputs and x is the output, that's where this graph comes about. And if you look at this, we don't have vertical tangents, right? We have a horizontal tangent, right? So how do you rewrite y equals a cube root of x or y equals x to the 1/3 in terms of x? Well, what you're going to have to do is you're going to have to cube both sides. So that makes this function x equal to y cubed. And now if we go and find the derivative, right? And the derivative would be dx, the derivative of x with respect to y. And in this case, it'd be 3y squared. Using the chain rule, we're going to take the derivative of y with respect to y. So that'd be dy over dy. Well, that's just 1, right? So dx over dy is equal to 3y squared. All right. So we need that. Remember, we need dy over dx or dx over dy if we're trying to find the arc length. And so we're going to integrate this from -2, which is actually a y value now, to +2, which is a y value, right? Because our y values are the inputs, and these are the inputs now. Okay, so basically it's graphing the inverse relationship of this, right? That's what we basically did. All right. Okay, so let's go about finding the arc length. So let me slide this up. Okay, so my arc length L would be exactly the integral from -2 to +2. The square root, that would mean my integrand would be 1 plus, and it'd be the 3y squared, because that's my dx over dy, 3y squared, and then multiply that by your dy. Well, clean this up. That would give us the integral from -2 to 2, the square root of 1 plus 9y to the 4th dy. All right. So then these, remember, arc lengths, you really want to go and just put them into your calculator and find the approximate value. Okay. So let's go do that. Let's go put that into our calculator and we'll come back.
With our calculator, we're going to press alpha, window, and then select function integrate number 4. And then we want to integrate from -2 to 2. And we want to integrate the square root and 1 plus, and then 9y to the 4th. So you could, instead of y, you could type x. So this time I'm going to show you, okay, what if we type y? So y is right here. I have to look for it real quick. Right here in the number 1 key. So we have to press alpha 1 to get the y, and then raise to the 4th power. Now, if we do it this way, okay, then the dy, it needs to be dy, not dx, right? So if this is x, we can type dx here, all right? So we have to go back and press alpha 1 to get the y. And if we press enter, we'll have our answer, okay? So 17.261, and 1 because the 6 is going to cause the 0 to round up by 1, all right? So that's how we integrate it with the calculator.
So from our calculator, we now realize that this integral is 17.261, and that'd be the length of either y equals x to the 1/3 or cube root of x, or x equals y cubed. They're the same. They're going to be the same length because you've just transformed this. Okay. So here's another problem. This is the function y equals x squared minus 4 times the absolute value of x minus x. And we want to find the length of this curve from x equals -4 to x equals +4. So here there's a problem at x equals 0, but it's not because there's a vertical tangent. There's actually a corner there. So we have a corner at x equals 0. All right. All right. So what we need to do is basically what we're going to do is we are going to find the length from -4 to 0. So we can find that. And then we're going to find the length from 0 to +4. And that's basically how we're going to do it. Okay. Now, this in absolute value is really hard to integrate. Like there's no antiderivative for absolute value of x. So we got to write this as a piecewise function because really it's two pieces, right? It's going to be this piece and then plus this piece. Okay. So y equals x squared minus 4 times the absolute value of x minus x is equal to, okay, so what changes this is what x is, right? So what does absolute value do? Well, absolute value, if the x is negative, it will cause this to be negative. So if x is negative, I can't just leave x. I actually need to multiply by -x, okay? So what this means is we have x squared minus 4. Instead of the absolute value of x, I'm going to replace it with -x minus x. So we're going to make this, we're going to take whatever the x is and multiply by a negative. And when do we want to do that to make this positive? We want to do this when x is less than 0. So we want to multiply the x by a negative when the x is negative, right? Because when we multiply a negative value times this negative, it's going to make it become positive. All right. So what do we do if this x is positive, right? Well, we don't do anything with it, right? So this is going to become x squared minus 4 times just x, right? We want to keep it positive, or when it's 0, we just want to keep it the same, minus x. So we're going to do this one when x, we're only going to do this when x is greater than or even equal to 0. So cleaning this up a little bit, my y for this becomes the I started writing an integral. Whoops, what am I doing? Change up. It's a piecewise, right? So we're going to put this brace. And it's going to be x squared. And this is actually positive 4x minus x. So that's going to be plus 3x. So it's going to be x squared plus 3x when x is less than 0. And this one's going to be a negative 4x minus x. So that's going to be negative 5x. So this one is x squared minus 5x. And we're going to do that piece when x is greater than or equal to 0. So really what this is y equals x squared minus 5x. And this piece right here is when x is less than 0, it's y equals x squared plus 3x. All right, so what we're going to do is on the interval from -4 to 0, okay, not including 0. And then we're going to use this one when we start at 0 and we go to 4. Now, why is this a closed dot, open dot? It's because of the piecewise function, right? When x is less than 0, right? So that's this part right here, okay? So to find the arc length, I'm going to have to find, this is y in terms of x, so I'm going to have to find dy over dx. So my dy over dx for this one would be 2x plus 3. And for this one, my dy over dx for that piece, it's going to be 2x minus 5. So to find the arc length, I'm going to break it up. I have to break it up into two integrals. So my arc length would equal the integral from -4 to 0, the square root of 1 plus my dy over dx for this piece, which would be 2x plus 3, squared, and that's in terms of x, so integrating with respect to x, and then plus the integral from 0 to 4, the square root of 1 plus, and then 2x minus 5 squared, and that's also dx. Okay, so once again, we're going to put that into our calculator, all right, and we're going to come up with an approximation for this. This is actually the exact length. I mean, this is an expression for the exact length. It's just, this is integrating these square roots with 1 plus and a square is really, really, really difficult. And it's really kind of beyond this class. Okay. All right. So that's why we're using a calculator. All right. So let's go put this in the calculator and then we'll come back.
And then for this one, we want to type in alpha window for integrate. And then we want to type in -4 for our lower bound, 0 for our upper bound. And then our integrand is the square root of 1 plus, and then parenthesis, 2x plus 3. And then we want to square that. And then dx. And then when we want to add to this, the integral. So 4 again. And we want to integrate from 0 to 4, like I said. And then square root. And then 1 plus. And then 2x minus 5. And squared, and then dx. And press enter. And there we have it, 19.556 for our second answer. And so that's how you integrate functions that aren't smooth curves. In other words, they're not differentiable. Okay?
So from our calculator, we got an approximation of 19.556. All right. And so that's how you deal with problems where the function is not differentiable at a point. You can rewrite some of them. You can rewrite, all right, and rewrite it as x in terms of y. So x is the output, y is the input. Or in a problem like this, you could break it up and integrate two pieces to it. Okay.